So in today's lecture, we will see what is a microfabrication on plastics. Microfabrication on plastics, right? So the outline of this particular lecture includes the introduction. Introduction, we have the techniques description and comparison of techniques, and we have the selected techniques, and we have conclusions and references. Okay. So the introduction. If you come to the introduction, the aim of this is to manufacture transistors on plastic substrate, right? And what are the potential applications or flexible displays, potential application of flexible displays, and low cost identification tags, smart cards, and disposable sensors. So smart cards and disposable sensors. Flexible displays, low cost identification tags, smart cards, and disposable sensors, and application development, application dependent processing. So if you come to the properties, we have the mobility. So whose switching speed of the device, switching speed of the device, and we have polysilicon approximately 50 to 100 centimeter square volt per second, and we have this was what we have seen. So it is polythiophene, and we have the year of mobility versus the year manufacturing. We can see. So we have the mobility. If we have the mobility versus year. So in 2000, starting from 1986, 1988, 99, 98, 1990, 92, 94, 96, and we have the different variations, so which was taken from one of the journals, right? So journals were taken. So these are some of the properties what we need to understand the fabrication of plastics. So on-off current ratio whose desired is around 10 power 6, and operational stability and processability. So process requires the optical lithography, soft lithography, and replica molding, solvent-assisted micro molding, micro transfer molding, micro contact printing, micro molding in capillaries, and hot embossing. Right. So the next is the near field phase shift lithography. Near field phase shift lithography, inkjet printing, screen printing, die printing, laser patterning. And optical lithography is what are the advantages? Proven technology, large area and complex patterning possible, high resolution, and we have the disadvantages of expensive process. Exposure to etchant reduces lifetime and performance. And advantage proven technology, large area and complex patterning possible, high resolution. We have disadvantage, expensive process. Exposure to etchant reduces lifetime and performances. So we have the replica molding. We have the advantages. Master copy can be used several times. High resolution possible. And the disadvantage is breaking of patterns and lift up is not smooth. So solvent assisted micro molding. So we have the elastometry rather than a rigid mold. Solvent instead of high temperature. Much faster than the time consuming capillary filling of mimic. So disadvantage is breaking of patterns. Lift up is not smooth. So this is for the solvent-assisted micromolding. So hot embossing process, we have the advantages: extremely precise and simple technique, cost-effective small-scale fabrication technique, time-efficient, fast process. Disadvantage is high temperature required. Hot embossing process, pattern transfer by controlled mod insert in a polymer, right? So polymer. So the disadvantage is high temperature is required here. So that is what hot embossing process. Near field phase shift lithography, we have the disadvantages: complex patterning required for transistor not possible. So this is what the near field phase shift lithography. The disadvantage is complex patterning required for a transistor is not possible. So micro contact printing. So we have the advantages. The advantages is large area printing, forms encapsulated device, resistant to fracture while bending, long device lifetime. Disadvantage is complex patterning process, etchant reduce device functionality, right? So micro molding in capillaries. Micro molding, we have certain advantages. So it's a high fidelity replication, high resolution feature possible. So disadvantages: polymer is required to have low viscosity, time required for patterning increases with area and channel length. So this is what micro molding in capillaries, that is what mimic we tell. So this is what the PDMS, it is a polymer, and we have the precursor, and polymer is being deposited on the precursor on the substrate. So we have the inkjet printing. The advantages of using inkjet printing is low manufacturing cost, complex patterning possible, and high throughput. Right. So the disadvantages are limited feature size. Advantage is limited feature size. Okay. So we have the inkjet printing. The advantage is low manufacturing cost, complex patterning possible, high throughput, and disadvantage is limited feature size. So screen printing, the advantage is low fabrication cost, very high throughput, complex patterning possible. Disadvantage is limited feature size. Disadvantage is limited feature size. So these are some of the advantages and disadvantages of screen printing. So dry printing, we have the advantages of high throughput, simple process. The disadvantage is change in properties of deposited films. Limited chemicals can be deposited. Limited device lifetime. This is what the limited device lifetime is. We have the advantages of high throughput, simple process. Disadvantage is change in properties of deposited films. Limited chemicals can be deposited. Limited device lifetime. So laser patterning, the energy of beam is approximately 1 joule per centimeter square, and advantage is high throughput, simple process, high resolution, and disadvantage is limited device lifetime. Limited device lifetime. So the comparison, if you see, the optical lithography is around 0.02 and channel length in micrometer is around 2.5, and throughput is centimeter square per second, that is 0.56. And replica modeling, the channel length is around 30 nanometer. Solvent assisted micro modeling is around, the channel length is around 50 micrometer. Micro contact printing, the charge mobility is 0.3 and channel length is 50, and the on-off ratio is 10 power 6 and comments is complex process. And mimic is around 0.3 and channel length is 10 and on-off ratio is 10 power 6. We continued inkjet printing. It is the charge mobility is centimeter square volt per second 0.01 to 0.02, and the channel length in micrometers is 5 and throughput is centimeter square per second is 10 to 10 power 3, and on-off ratio is 10 power 5. Near field phase shift is 50 nanometers. Screen printing is 0.01 to 0.03. The channel length is 10 micrometer and throughput is centimeter square per second is 165. Dry printing, the charge mobility is centimeter square per volt second is 0.01 and channel length is 22, and whereas the throughput centimeter square per second is 16 and on-off ratio is 10 power 5. And the laser patterning, the charge mobility is 0.01, channel length micrometer, and throughput is centimeter square 10 power 4, and on-off ratio is 10 power 4, and the comments are low device life. So in case of inkjet printing, the process description, spin coat polymer on a substrate. Substrate, what the other is called description of photolithography, inkjet printing of conducting polymer, spin coating of semiconductor, spin coating of dielectric, inkjet printing of gate, So this is what inkjet printing. And conclusion, inkjet printing provides a viable low-cost process for the manufacture of transistors on plastic substrate. Okay. So this inkjet printing, the process description is spin coating PI on substrate photolithography, inkjet printing on conductive polymers, spin coating of semiconductor, spin coating of dielectric, inkjet printing of gate, and this is some of the descriptions of inkjet. And if you see the continuous forms of comparison between different modes, so it's optical lithography, replica modeling, and solvent assisted micro modeling, micro contact printing, and mimic, we can see these are the comparisons. These are the comparisons in process of optical lithography, replica modeling, solvent assisted micro modeling, micro contact printing, and mimic. And we have the inkjet printing, near field phase shift, screen printing, dry printing, and laser printing. Right. So the patterning, if you come to the laser patterning, the energy of beam is around 1 joule per centimeter square, and the advantages are high throughput, simple process, high resolution, and the disadvantage is limited device lifetime. Disadvantages are limited device lifetime. This is what the laser printing or disadvantages of using laser printing. Right. So if you see the dry printing, the advantages of using dry print are it is a high throughput, simple process. Disadvantage is change in properties of deposited films. Limited chemicals can be deposited. Limited device lifetime. If you see the screen printing, we have the advantages of low cost fabrication, very high throughput, complex patterning possible, and the disadvantages are limited feature size. Limited feature. With dry printing, we have the high throughput, sample process. Disadvantages is change in properties of the deposited films. Limited chemicals can be deposited. Limited device lifetime. So screen printing, we have the advantages like low fabrication cost, very high throughput, complex patterning is possible, and the disadvantages limited feature size. Limited feature size, right? So micro molding in capillaries, though we have the advantage high fidelity replication, high resolution feature possible, and the disadvantage the polymer is required to have a low viscosity, time required for patterning increases with area and channel length. So these are some of the important information regarding the micro contact printing. We have the advantages and disadvantages. We have the advantages as large area printing forms encapsulated device, resistant to manufacture while bending, long device lifetime, and the disadvantage is complex patterning process, exchange reduced device functionality. And near field phase shift lithography, we have the disadvantages. So complex patterning required for transistor not possible, and hot embossing process, we have the advantage extremely precise and simple technique, cost effective, small scale fabrication technique, time efficient, fast process. The disadvantages are high temperature are required. So solvent assisted micromolding, we have the elastometer rather than a rigid mold, solvent instead of high temperature, much hotter than mimic, and the time consuming capillary filling of mimic. And disadvantage is breaking of patterns and lift up is smooth, it's not smooth. So these are some of the advantages of replica modeling. Most master copy can be used several times, high resolution possible, and the disadvantage is breaking of patterns and lift up is not smooth. If you come to the optical lithography, the advantage of optical lithography is we have the proven technology, large area and complex patterning possible, high resolution, and the disadvantage is expensive process, exposure to enhance, HN reduces lifetime and performance. And we have the continued we have certain features like near field phase shift lithography, inkjet printing, screen printing, dry printing, laser printing, and the process includes optical lithography, soft lithography, replica modeling, solvent assisted micro molding, micro transfer molding, micro contact printing, and micro molding in capillaries and hot embossing. Right. So these are some of the properties what we have seen, what we can see in the coming features of designation of plastic. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.